All right. So this is what I'd like for you to do, ladies and gentlemen. On your paper, on your notes somewhere, I would like for you to draw two graphs. I think we started this conversation a couple days ago and then got cut off probably by the bell, because that usually happens. Okay. We're going to do a little graph matching. Okay. Yeah. Am I frozen? Yeah. Oh, I'm so sorry. There you go. Thanks for reminding me. I don't look back, so I don't know. All right. We're going to do displacement versus time. You're going to watch me. You ready? Here I go. Watch carefully. Eyes are up here, so I don't have to do this too many times. All right. Go. Stop. Okay. So graph that if you can. I'll do it one more time so you can see it. Get a first round down. Okay, I'm going to do it again. Here we go. Go. Stop. Once you think you've got that, check with your neighbors. See if they agree with you. Up here, I did, yes. How are we doing? All right. Madeline, can you get us started? What did you start with?
Thank you.
You're welcome. How did it start?
Oh, with me?
Yeah, you.
So it stayed on the x-axis for a little bit.
Okay.
And then it goes it's not like that steep of a slope, but it goes up.
Okay, like just with kind of a little slope like that. Okay.
And then it goes flat lining down for a little bit. And then with a steeper slope, it goes down past the x-axis.
Okay, nice. Thank you so much. All right. Do you guys agree with her, first of all?
Yes.
Awesome. Okay. Now, this is what I'd like you to do. On your displacement versus time graph, I want you to mark some certain times here. I'm going to call this one T equals, or T1. I'm going to call this T2, T3, T4, and T5. And I'm just doing that so I have a nice reference. On this graph over here, we're going to label this axis velocity. And down here, we're going to do time. I feel like we kind of started talking about this, but we haven't really tried it yet. So what I want you to do, you can talk to your table mates. That is absolutely fine. I want you to see if you can translate the displacement versus time graph into a velocity versus time graph. What does that mean? Talk to your table and see if you can figure it out. We'll go through it in just a second, but see if you can think it through. I bet you can do it.
There is something about
Solar LED lights.
Is this life plans over here?
Yeah.
It's true. It's true. It's good investment, though, my friend. All right. How are we doing? Kind of? Like, you don't want to turn it in to be graded, but you're ready to have a conversation. You would turn it in? You're feeling that good? Okay. All right. Jacob, get us started. You don't have to do the whole thing, but get us started. I talked to you. I said your name, Jacob.
Me?
Yeah, you.
How it starts?
Yeah.
Well, it just go along the x-axis.
Just go along the x-axis. So like a slope of 0?
Yeah, to start.
Okay. Sorry, I'm marking my times. All right, so I've got a slope of 0 to start. Like this?
Yeah.
Okay, so it matches the displacement versus time graph. Okay.
It's gonna go up a little bit.
Okay.
When you started walking.
Okay.
It's gonna go constant again.
So it's going to go constant, like up here? Is that what you mean? Or do you mean like this?
No, up and then constant.
So there's some sort of up. Something happened. And then it's going to be constant?
I think so.
Okay.
Can I not do that?
You totally can do that.
Do what?
That?
That's possible.
Sure.
And then you
Instantaneous
stop.
change of velocity? Sure.
And then you stopped.
And then I stopped. So what does that mean?
That it's gonna go back down to the x-axis.
Okay. For that next piece?
And
All right.
You went backwards, so it's gonna go farther up than in between T1 and T2.
So it's going to go up here?
Yeah.
And for how long?
Until T5.
Until T5. What do we think? Do you agree with him? Do you not agree with him?
I don't agree with you.
Ooh, that is always indicative of a problem.
You should always be confident of yourself.
Or, I mean, there's sometimes like, if somebody calls on you and you're like, oh, but yeah, I mean, like, stand with your answer. Do you all agree with him though, or no? Yeah, no. Okay, it's like, let's go piece by piece. Do you agree with this one, the 0 to T1? Yeah, I agree with that. The story is that I'm not moving. If I'm not moving, what's my speed? 0. What's my velocity? 0. Yeah. All right. Do we agree with this part here?
It still took you time to get to that walking pace.
It did. And we're just going to have we're going to wave our hands for that little moment. We'll get there today, but I'm just going to dotted line that for right now. I'm okay with this. I think this is fine. I think that's okay. Because I have a constant slope, so I have a constant speed. What did I do after I walked forward for a while? I did stop. I stopped from T2 to T3, didn't I? Yeah. Then what did I do after that?
Oh, does it have to go below since you went backwards?
Because this is velocity, isn't it?
Yeah.
And can velocity be negative? What can't be negative? What was it? Speed. Speed is never negative. Speed is always just going to be a number. But velocity absolutely can be negative because we want to be more descriptive about where I'm going, right? So I was going forward, and then now I'm going backwards. So it actually does need to live down here. Yeah. Yeah. You were very close. I am very excited for you. That was very close. So I'm going to throw this one down here. And you did say, and I appreciated this part, that this distance from the axis right here has to be bigger, doesn't it? Because this slope is really, really negative, whereas this first slope is just kind of like slightly positive. Is that okay? Okay. We're going to come back to this concept after we finish our lab, but I wanted to kind of get that conversation going. All right, so you can put those notes away for just a few minutes. Everything good, ladies?
Yeah.
Fantastic.
I got in trouble.
I'm sorry.
Big trouble.
All right. So let's not make it a distraction. All right, here we go. So this was the lab you were working on yesterday. I want to clarify something for the graphing so that you get the graph that we're expecting you to get. Okay? So I took another picture of the like diagram. Okay? You may have measured and labeled these going up or going down. It really doesn't matter. The thing that I want you to do when you're actually graphing your data is that the time that it took from where you released the ball to the first distance, we're going to call that 50. It traveled 50 centimeters. Okay? So in the other class, I had about half of them that had labeled it the other way, which is not a big deal because you wrote things in pencil and you can cross it out. Really not a big, you with me there? It's like really not a big deal. So we're just going to go with it. The shortest one is going to be 50. The next one is going to be 100. The next one's going to be 150. And the longest one is 200 centimeters. Is that okay? Okay. So I'm going to let you get started on your labs. I'm going to interrupt you at some point, I'm sure. My hope for you, my goal for you is to get at least, I need to say one other thing, I'm sorry. To get at least one set of data graphed. Listen carefully, please. Please stop talking.
Stop talking.
Every person needs to make a graph, okay? Time needs to be on the x-axis. I don't care if you do it portrait or landscape, it doesn't matter to me, but time needs to be on the x-axis, displacement needs to be on the y-axis. You're going to graph one book in one color, 2 books in another color, and 3 books and yet a third color on the same graph. Okay? And everybody needs to do analysis questions. Okay? Cool. All right, get started.